Okay, so if we read through the problem, they've given us a formula. We don't necessarily have to know how the formula works in electrical science or anything like that. Um, if the current in the electrical system is decreasing at a rate of 8, forget what that is, amps per second. So they explain that I is equal to the current, right? So this sentence, the current in an electrical system is decreasing at a rate of 8 amps per second. That means I prime equals negative 8. Okay, because I prime, that's our calculus notation for the rate of change of something. And then it's a constant negative 8 amps per second. So that's why I put a negative sign here, is because it's decreasing. And that's why there's no variable, because it's constantly decreasing. So decreasing at a rate of negative 8 amps per second. So decreasing at a rate of 8 amps per second. The voltage remains constant. So before I move on from those words, the voltage remains constant. That means V prime equals 0, right? The slope at any point, the instantaneous rate of change at any point for the voltage is 0. Okay? And then V itself is always equal to 20. They're keeping it constantly at 20. The rate of change is 0 because it's constantly at 20. And then they're asking at what rate is the resistance increasing? So they're asking for R prime, because R prime, that's the derivative of R, that's telling us how fast something is changing. And they said when the current is 56, there's no apostrophe there, there's no derivative, because it's saying what the current value of I is equal to. Okay, so let's try to put all that together. We need to calculate something regarding a derivative. So let's take a derivative of this equation. So the derivative of V with respect to time is equal to I prime R plus I R prime. And the reason is because of implicit differentiation and because of the product rule. These are two different functions with respect to time, right? I depends on how long we've been going. R depends on how long we've been going. And if we take a derivative of those, since we're taking a derivative with respect to time, because that's the underlying variable under all these letters here, then we have to use implicit differentiation. We don't know what the derivative of I is with respect to time, so we symbolize it with I prime. And then using the product rule, it's the derivative of the first function times the second function kept the same, plus the first function times the derivative of the second function. Okay, so there's our derivative equation. We can plug in the known values, and you'll see we're still missing something, but we'll be able to get it from what we know. Negative 8 goes in for I prime. R we don't know yet. I at this moment is 56. R prime is unknown. That's the thing we're trying to solve for. So we just need to know what R is, and then we can solve this equation for R prime. And we can quickly get that from the fact that V equals IR. Right? They told us the voltage is currently 20. I is 56. And then R is the thing we need to solve for. So when the voltage is 20 and the current is 56, you can solve for R, divide 56 from both sides. Then you can simplify. That's 10 over 28, which is 5 over 14. So that's our R value. So if we plug that back into our equation, now it's just algebra. So negative 8 times 5, that's negative 40. Actually, let's cross simplify that. That's negative 4 over 7. So that's negative 20 over 7 plus 56 R prime. Still trying to get R prime by itself, so we'll add that 20 over 7 to both sides. And then we'll multiply both sides by 1 over 56. So that's 20 over 56 times 7 equals R prime. And then if you simplify that, that's 10 over 28. We've already done this. This is 5 over 14. And then 14 times 7, that's 98. So I got 5 over 98.